The towering primary mirror of NASA's James Webb Space Telescope stands inside a clean room at NASA's Johnson Space Center in Houston. This photo shows Chamber A being prepared for the telescope. And here's NASA's James Webb Space Telescope placed in Johnson Space Center's historic Chamber A on June 20, 2017. Those were the official photos. Last summer, the media only got to look at the action through double-paned windows. But we did get to see this massive banner. And look, people talking about space telescopes and stuff. Pipes to make vacuums. Do not touch. Another terrible photo of the telescope from below, looking through glass. These vacuum chambers are kind of a big deal. They're located in that building behind the tree. After spending 3 months at a temperature of just 20 degrees Celsius above absolute zero, the massive James Webb Space Telescope emerged from a large vacuum chamber at the end of 2017. Now, after reviewing data from testing done there, scientists have given the instrument a clean bill of health, moving it one step closer to space. We now have verified that NASA and its partners have an outstanding telescope and set of science instruments, said Bill Ox, the Webb Telescope project manager at NASA's Goddard Space Flight Center in Greenbelt, Maryland. We are marching toward launch. Lots of tests. The $10 billion telescope underwent tests inside Chamber A at Johnson Space Center, which was built in 1965 to conduct thermal vacuum testing on the Apollo command and service modules. Beginning in mid-July, after the telescope was cooled down to a temperature range of 20 to 40 Kelvin, engineers tested the alignment of Webb's 18 primary mirror segments to ensure they would act as a single, 6.5-meter telescope. They did. Later, they assessed the fine guidance system of the telescope by simulating the light of a distant star. The Webb telescope was able to detect the light, and all of the optical systems were able to process it. Then, the telescope was able to track the star and its movement, giving scientists confidence that the Webb instrument will work once in space. Webb still has a ways to go before it launches. Now the project scientists know that the optic portion of the instrument can withstand the vacuum of space, and the low temperatures at the Earth's L2 point it will orbit in deep space. They must perform additional testing before a probable launch next year. Next stop, California at the end of this month, or early in February. The telescope will move to Ellington Field in southeast Houston, where it will fly aboard a C-5 aircraft to Northrop Grumman's facilities in Los Angeles. There, the optical instrument will be mated to its spacecraft and sun shield to form the complete telescope. Subsequent tests will determine that the sun shield deploys properly and that the combined instrument can withstand the vibrations produced during launch. Finally, the telescope will be flown to French Guiana for a launch aboard an Ariane 5 rocket no earlier than spring 2019. NASA is taking all of this care with the extremely valuable Webb telescope because it will be difficult if not impossible to service due to its observing location, which is farther from Earth than the Moon. Moreover, before Webb can begin to observe light from the very first galaxies in the universe, it must perform a complicated ballet in space. Scientists are especially concerned about the deployment of the telescope and its sunshield, which will keep the instrument cold and allow it to detect faint, infrared signals from distant sources. More than 180 devices must work properly for the sunshield, which measures 14 meters by 21 meters, to deploy. That is what makes us most nervous, admitted Jonathan Homan, project manager for Webb Telescope Test Team in Houston. Listing image by NASA.